My experience 3D printing, I guess, started when I was in architecture school here. When I was here, they got the first 3D printer, for the school. And so I had a little bit of experience having stuff printed for me. I started 3D printing myself when I started running the design works, the fabrication lab for the School of Design here at Syracuse. And they had a FDM, which is fused deposition modeling, essentially hot plastic laden layers. And so I got a lot of experience there. From there, I built my own RepRap, which is an open source 3D printing project. The goal is to design a 3D printer that can print all of its own parts, so it's self-replicating. And then I came here and got more experience on the different machines that they have there, and that's my experience, I guess. My definition of 3D printing is any additive, computer-controlled process. So instead of taking material away, like a CNC or a CNC mill or something like that, it is, whatever way they're doing it, building up layers of material instead of taking them away. What can be 3D printed? It is rapidly changing all the time, and it's, the traditional stuff is plastics or starch powder, those kinds of things, but there are metal printers, there are all different kinds of filaments that are coming out now for the plastic printers that are printing metal infused plastic and wood infused plastic, and there are 3D printers that are printing tissue, like human tissue, other kinds of mice, trying to print body parts. They're printing bone, they're printing all kinds of food. So it's really, the question is, what can't be 3D printed at this point? What do you see the future of 3D printing? I think the biggest drawback of 3D printing right now is that machines are material specific. So generally speaking, machines print one kind of material at a time. So I think once they figure out the way to print multiple materials at the same time, including printing electronics, that's going to be the game changer. The other thing is speed. Right now, in terms of manufacturing, at least, 3D printers compared to injection molding is a lot slower. So if you're talking about doing production scale stuff, it's the speed that's going to have to come up.
Okay, so we've got two different 3D printers here. The first one is an Envision. It prints in some kind of proprietary plastic. It has a very high resolution. It's printing, it's selective laser sintering. So there's a laser in there that cures the material as it's deposited. It builds builds a support material out of wax, which is then melted off in the oven. It's very high resolution, but it's slow and it's expensive. Next is the powder printer. It prints a powder, which is like a starch, and the way it works, you can even see it going, is it puts a very fine layer of starch, and then there's a print head that prints a binder. So wherever the model is going to be solid, it sprays a little binder, and then it'll come out and put another little fine layer of starch on there and print the binder. So it builds up that way. Resolution isn't quite as good. The models are delicate when they come out, but it's pretty fast, and the powder is relatively inexpensive. Okay, so, and then we've got the MakerBot, which is an FDM printer, which is basically the most fancy kind of hot glue gun you can imagine. There's a filament of, this is PLA, which is a biodegradable corn-based plastic that is heated in the print head here, melted, and then extruded out, and it just goes around building up layer by layer.
All right.